Mark Scantlebury, President and CEO of Extreme Telematics, and Sean French, the President and CEO of Voodoo Injection Management. And I'll turn it over to Mark to start the presentation.
Thanks, Mark. So the title, it's a bit of a mouthful, Reliable Reduction of Chemical Usage for Field Injection Pumps. Basically what we're going to talk to you about today is how ETC and Voodoo have partnered together to deliver this solution to save on chemical injection costs with a retrofit solution. So just a bit of background on ETC. So we're a Canadian private corporation. We're headquartered here in Calgary. Founded in 2001, and our specialty is electronics R&D. So low power, wide temperature range, hazardous locations approved electronics, so perfect for the oil patch here in North America. To date, we specialize a lot in plunger lift. We make the plunger lift controls that you see white labeled. They're branded under a whole host of names all across North America and worldwide. So you probably know our stuff already, but you may not know it as ETC branded products. So what we bring to the equation here is this controller platform. So we've designed it for operation in Canada. So the same things that Sean and did for Voodoo, we've already addressed in plunger lift, right? The low power, the wide temperature range, operates from -40 to +70, and it's class 1, zone 0 intrinsically safe. So you can put this anywhere at the well site or around the well site. There's no safety concerns. You can put it in the most hazardous locations. The low power draws under 0.5 milliamp average, so you get 8 months of standby, which is more or less unheard of in controls in this environment. And then we brand it for service companies, and this is the platform that Voodoo is based on. So I'm going to pass it over to Sean, and he's going to tell you a little bit about the Voodoo application itself.
Hi folks, pleasure being here today. Just give you a little bit of background about myself. I've been in the oil and gas industry for 21 years now. I worked for Untitled at Dallas and a couple other companies around. And in my role as a senior foreman, budgeting chemicals was always the hardest thing to do. We always seem to be over-injecting chemicals in the field, overrunning our chemical budgets and everything like that. So I wanted to develop a system and a process that could retrofit onto everything we already have and actually meet targets. So the questions that always came to mind and were always asked me was, is over-injection costing your company money? Thousands of dollars a year. Every field that I looked after, we did have over-injection. Chemical companies nowadays have refined their chemicals so well that no longer do we need 6 and 7 liters a day to treat corrosion or wax all or anything like that. We only need 1 or 2 liters a day. And the existing pumps that are out there and even new pumps on the market today are not reliable at continuous injection at those low rates. So what I've done is built a retrofit system onto that to meet those rates. Is your chemical budget on target? Are operators having to spend extra time on location repairing pumps? Absolutely. That was one of the biggest bitches I would say that the operators had to me in general meetings and everything like that when we were reviewing budgets, reviewing chemical consumption reports and everything like that. And they said they'd on average spend 5 to 10 minutes per location, every location a day, either fixing a stalled pump, repairing packing, resetting the pump to try to get to that low rate or whatever. And it just seemed consistently across the board that was one of the operators' biggest time consumers on location was messing around with chemical pumps. So the problem is the pumps that are out there on the market today are mostly just all positive displacement pumps. We're trying to achieve low rates here, so it's a single piston positive displacement pump. We know when we're trying to move chemicals, especially viscous chemicals such as corrosion inhibitors, wax solvents and stuff like that, that they, at a liter a day, lots of times you're not even displacing the line from the chemical tank to your pump. So that chemical tends to sit in there, starts to plug up your lines. The temperature change, most of these chemicals are aromatic based, methanol, petroleum based. They sit for any amount of time, they start to break out, creating vapor locking, stalling the pump, plugging up your seats on your pump or whatnot. Lack of precision control on these pumps. Most pumps, even the new solar pumps and stuff today, the precision control just isn't there. Lack of remote control capabilities. We all know that there is no real way other than on-off operation to control these pumps until I came along. Chemical starts to plug up in lines, like I said, displacing that line from the chemical tank to here, especially with our temperature changes. Low rates are not reliably achieved. My experience in the last 22 years is these type of pumps, positive displacement pumps, you're not going to get a reliable continuous injection at low rates. Some offer pulse injection, some offer on-off, stop-start, but that's still not continuous injection to achieve a low rate. Conventional solutions set the pump at a higher rate, injecting more chemical. Let's face it, your operator spends 2 or 3 days trying to achieve 1 liter a day with his existing pump. He gets frustrated, he turns it up, walks away for the next couple days. Maybe the next shift comes, picks it up, tries to do it again. It's just not achievable, it gets frustrating. Visit the well site more often. We're all trying to cut back on ops costs. We've installed SCADA in many of our well sites so we can pull it up on our computer. Our operators can look at it. They can see if the gas well's still flowing, the pump's still pumping, you know, your downhole pump, your pressures, temperatures, but can you tell whether your chemical pump's pumping or not? Can you control chemical rates via SCADA with your existing system? Probably not. That's what I've brought to it. So they have to visit the well sites more often. They have to go there every day to ensure that critical chemical pumps injecting corrosion inhibitor on a sour gas system, or that wax solvent is getting injected and not been down for 2 or 3 days. I see lots of times more and more people are going 2 and 3 days in between visiting well sites, especially for non-critical well sites. Another conventional solution is on-off operation. I've actually come across this a couple of times, and I don't think it's continuous injection, and really is more spot treating or batch treating. I've seen it everywhere from turn the pump on for 1 day, turn it off for a day, turn it on for 1 day, turn it off for a day. I've seen it right down to start it up for 2 hours, leave it off for 6, start it for 2, leave it for 6, leave it overnight, shut off. Come back, do that for closer wells. Not continuous injection, folks, I really don't think. You're not getting continuous protection on your pipeline or your downhole or anything like that. You're getting little spot injections. Move to an electric pump, typically solar. That seems to be a pretty good push for lots of companies. Unfortunately, they still have the same inherent problems. Still a positive displacement pump for the most part. The pros, there are many companies offering electric pump solar solutions. Eliminate stalling for the most part. You don't have that pneumatic stalling with conventional pumps. Lower rates can be achieved, but be cautious with that as well, because some of the cons are injection duty, very slow. I've seen some of these pumps where they slow it down, it almost works on a screw type. So to get that liter a day, it takes up to 15 minutes to do 1 stroke and then return, and then another 15 minutes. So you can imagine with this viscous chemical, especially temperature changes, you're not even displacing it from the tank to the pump. You're going to run into problems with the vapor locking. You're just moving the chemical very slow. Methanol is not so bad. Other chemicals still subject to that. Still subject to vapor locking. You're not changing anything. You're moving everything so slow. It still gives the chemical time to break out and into its different products. Not close enough to continuous injection. It can be multiple minutes to hours in between injections. I've seen this as well. Some of the pumps out there, if you ask for 1 liter a day, they take the calculation of the volume of the pump head, and they just put 1 liter a day. This is my calculations. I'll need to inject every 24 minutes, 1 pump stroke every 24 minutes. That's how they're achieving these low rates, but is it truly continuous injection? No. Is it giving you good protection of your pipeline, your downhole, your assets? No, it's probably not. Leads to long periods of time with no chemical being delivered. And that's just not continuous injection. If that was what we were trying to achieve, we'd probably just all be batching pipelines, batching downhole, that type of stuff, not continuous injection. We wouldn't have any pumps out there like this. So those are some of the pros and cons of both. The solution that I came up with is this patent pending process, and it is truly a process. What I came up with is a retrofit system that can be bolted onto any pump. This one's bolted on to your usual TXD 5100 quarter-inch piston. My system is a combination of the algorithm that's in the ETC control box that's suited for my application. The volume of fluid, piping, valves, everything like that is all part of the patent pending process. The pump is set to an optimal rate. That's the advantage of the system. To achieve that 1 liter a day, we're not trying to set this pump down to a liter a day. I think if you ask any operators out there, you say what would be the optimal rate for this pump, they would say 5 to 15 liters a day. They'd never have to touch that pump. They go there every day, it's stroking away nicely, that's an optimal rate. If you look up the specs for texting pump and anything like that, they were never engineered down to 2 and 3 liters a day. They know they have problems like that. There's been some retrofit systems. They've tried to address that problem, but you're still using a positive displacement pump with processed chemicals. Designed to inject and recycle back to the tank. So instead of over-injecting your chemical, if you're running your pump at 10 liters a day and you're only asking for 1, we would recycle that 9 liters back. Your pump's running at an optimal rate, it's satisfied, you're asking for 1 liter a day, we achieve that, and we recycle the 9 liters back versus over-injecting. A couple advantages of recycling it back to the tank is now for a lot of these processed chemicals that are made up of multiple components, it rolls your chemical tank. It keeps your chemical fresh in your tank. You don't have that sludge settling out over a couple months in your 300-gallon tank. You're not having your line plug off due to the chemical separating out in your tank. Gives you nice fresh chemical for treatment all the time. Controller manages injection and recycle to achieve the target rate. And the way that works is we take the algorithm on your target rate and the pump rate, and we divide that up, and it fits into a 2-minute cycle period. So we say it is true continuous injection because guaranteed injection every 2 minutes. So within that 2-minute period, you'll have an injection portion and a recycle portion, and after that 2 minutes is up, it repeats itself and repeats itself. So true continuous injection in that form. Benefits, retrofit system. Fits onto your existing pump you already have, whether it be solar, electric, pneumatic, it fits on there. So added benefit there is you're not replacing your pump with another new pump, new parts, teach your operators new methods on how to repair it. You don't have to try to get rid of your old surplus pump or what do you do with it, parts, everything like that. Retrofits onto what you already have. Pump is always running at an optimal rate. I think that's very important because that's where they're engineered to run. That's where they have the best consistency and reliability. Precision control and expanded low-end range of pump's capabilities. We can take that average pump that the manufacturer says, 5 to 15 liters a day, and we can expand that low-end range right down to a 1/4 liter a day if we want. Still keeping the pump pumping out where it was engineered to pump. That pump's running at 6 liters a day, we want a 1/2 liter a day, we can do that. We've just expanded the low-end range of that pump. Chemical's always moving, we've already kind of touched base on this. Avoids the settling in the tank, reduces setting up in lines, eliminates buildup in the pump heads. All the problems that the operators face day to day when they go to location, trying to achieve low rates. They sit there, they see the pump stalled, usually you either crack the bleed, waste a couple liters of chemical there, get it re-going. You're also exposing your operators to these very nasty, harsh chemicals. Chemicals recycled or used elsewhere instead of over-injected. We'll touch base a little bit about the elsewhere. We don't always have to recycle back to the tank. You'll see some added benefits definitely about that in a couple slides here. Continuous injection, like I said, it works on a 2-minute cycle period. So within a portion of that 2 minutes, you are guaranteed injection, which really does give you protection for corrosion on pipelines, wax treating, that type of stuff. Remote control capabilities. Our system is RS-485 Modbus compatible. So if you have existing SCADA on site, we can tie into your existing SCADA. You can have full control over your pump through SCADA. There's a couple other things we can do as well. Basic operations, very simple. I've dealt with a lot of operators and everything like that. Keep it simple, they'll like the idea, they'll use it. You make it very difficult, hard to use. You generally get, thing doesn't work, you don't like it, don't like the technology, and they leave. My system is very simple. 3 steps is all you need to do. First one is you set your pump at your optimal rate, where you believe that that is going to be the least amount of trouble, where it's going to run the best. Your next step is you simply enter your target rate into the box. Say your optimal rate for the pump's 10 liters a day, you enter 10 liters. Your chemical company says you only need 1.3 liters a day to treat this line. You enter 1.3 liters in. Your next enter into the box is just your average injection point pressure. This is pressure compensated, so we just need an average injection pressure. If your pipeline operates between 700 and 1200 kPa, enter 1,000 kPa and it'll take care of it. Obviously, it's a lot different if you're operating at 1,000 kPa versus 35,000 kPa injecting at a wellhead. So it is pressure compensated to make up the difference. So those are the three that you have to put in: pump rate, your target rate that's prescribed, your average injection pressure. You hit run, the controller does the rest. It'll figure out the algorithm from your pump rate to your target rate, incorporate the pressure compensation factor, and figures out the injection cycle in that 2-minute cycle period. Basic configuration. Motor valve is closed to inject, open to recycle back to tank. So we just rig in downstream of your pump. We don't touch the pump at all. We just split the flow downstream of it. So for a portion of your injection cycle, your prescribed rate would be going to your target. In this case here, it's wellhead or pipeline. The rest of it would be recycled back to the tank, roll in the tank. So for an example here, if you had the pump set at 10 liters a day and a target rate of 2, 2 would go here, 8 would go back to the tank, and that would repeat itself every 2 minutes. Dual pumps. One controller can also run 2 pumps. So if you have one running at the wellhead and one running down pipeline, one control box can control 2 pumps, 2 different rates at 2 different injection points. Pretty handy. I know lots of guys have a corrosion inhibitor, wax solvent, or whatever going down on a capillary string down the well's backside or whatever to handle corrosion, wax, paraffin, or whatever down the hole. And you also have one going to your pipeline here. Same issues with both pumps, trying to achieve low rates. My box can control too. Here's just a setup that we have here. Pump 1 is right here. Pump set at 7 liters a day, target rate 1 liter a day. Pump 2 set at 2 with a target rate of 2. Nice, easy setup, close, small footprint on location. Control box mounted on the wall. Solar powered, run outside. And away goes. Instruction sheet here, 3 easy steps. Right there, the operators can quick read. Just quick bullet for them, easy for them. Pumps are tagged, pump 1, pump 2, you just scroll through. Away it goes. So that's kind of a typical installation of a dual pump setup, small footprint. Pump splitting. This is also what we've designed to, instead of recycling back to your tank with your excess chemical, what we've decided to do here is to split the chemicals. And what this does is allows you to eliminate one whole pump, the maintenance of one pump and all the either fuel gas or electricity associated to drive that pump. So now with this setup here, what we would do is, say you need 10 liters to the wellhead, 20 to the pipeline, you would merely set your pump at 30 liters a day and just enter in the box, target 10 here, and the remainder would go back to your pipeline versus to your tank. So with this setup here, one whole pump's eliminated and all the costs associated with that other pump. Pump splitting, say for pad locations or where you don't have a large differential between your 2 injection points, we can run 2 control valves. Instead of like the last slide here, we have 1 control valve and check valves. Obviously, wellhead at a higher pressure than the pipeline. When this control valve opens, the pressure from the wellhead would shut your dual check valves, and flow would obviously take the path of least resistance to your pipeline. In this setup here, where their similar pressures are very close, what we do is we run 2 motor valves, and the controller tells one to close while it tells the other one to open, diverting the flow both ways. Once again, eliminating one whole pump, the maintenance and the driver of that pump. A couple of other features that we have on all of our boxes, whether you use it or not, or choose to. We have temperature compensation optimization. The way this works is we have a built-in thermometer built right into our control box. For this to work, you would obviously mount this externally from your building to pick up ambient temperature. This graph that we set up here for this customer, at 2 degrees and lower, they want 20 liters a day of methanol going into that well. As it warms up, it will slowly trim off, and what they're saying is at 10 degrees and warmer, we still want 4 liters a day going in there. So as you can see in Alberta, these temperature swings, even in September, we've achieved. So right here, anything below 2 degrees, full rate of the pump set. Anything above 10 degrees, it goes to its trim back rate, and it automatically reduces or increases in that span to compensate for temperature. Good example of this, I was doing some testing in our lab in Sundre there. In September, a couple of days in Sundre, we were down to 5 and 6 degrees at night, 24 degrees during the day. I had my pump set at 10 liters a day, and on average for the whole month of September, I only injected 4.5 to 5.5 liters a day with my pump set at 10. I had my low set at 4, my high set at 15, and it automatically changed throughout the day and night along that scale. Well, that's pretty big savings when you think about it. 30 days, pump set at 10 liters a day, and you only average half of that. That's half of the chemical savings right there. And keep in mind that's in September, as we know, and experience Alberta in winter months, all 12 of them. So that's just a nice feature that's built right in that you can use. A couple of other features, not built right in, but can be controlled through SCADA through the RS485 Modbus port, is you can automatically control off of gas rates, liquid rates, pressures, temperatures, anything like that. Whatever numbers you're pulling in through your SCADA system into your master, you can give us a brand new target rate back to our slave device. So say this is a corrosion inhibitor off of a compressor station. Both compressors are running, you're doing 100 decks of gas, you want 55 liters of corrosion inhibitor. One compressor goes down, you're saying, okay, well, at 50 decks I only need 30 liters. But do you think when that one compressor goes down, that's the first thing on the operator's mind is to go trim back that chemical? No, he's lining up mechanics, he's trying to troubleshoot. It could be multiple hours while you're still injecting at your full rate when you only need to be injecting half. So take a look at your uptime on your compressors and see, if you've got 5%, 95%, 96% uptime, that other 4% you're probably over-injecting or 100% over-injecting that whole time. That's for gas rates, liquid rates. If this was off of an oil battery or something like that, and this was wax solvent, maybe at 80 cubes a day, you need 40 liters wax solvent. But as some wells shut in or you're doing workovers, different things change. So basically, whatever numbers you're bringing in through SCADA, we can set this up, or the operators can set that up, change the endpoints, and you can automatically control off of varying conditions. If this was off the temperature, or sorry, I'll back up. This one off the temperature has really intrigued a lot of my customers. So they have their host at their compressor station, they have a thermal well coming in there, they already know their hydrate curve say 4 degrees. Well, if that pipeline starts to get into that 4 degrees, how do you tell your pumps to kick up the methanol out in the field without sending an operator out there or running the pumps already at a higher rate so you don't get into that hydrate range? With my system tied into Modbus and SCADA, as soon as that thermal well or RTD sees that you're getting into close to hydrate range, it could automatically send a signal out to 1, 2, 5, 15 wells in the field, have them automatically pick up that methanol rate, even by a couple liters a piece per well, get you out of that hydrate curve. If your pipeline isn't hydrated off, you haven't had to call out an operator, you haven't had to book a methanol truck or a pressure truck and pump a couple cubes of methanol away. It automatically took care of your hydrate before it formed. So those are some of the advantages, definitely, of tying the system into SCADA. Another advantage, say you shut your well down or whatever because your compressor goes down, you have to can your whole field. You're on SCADA, it's easy enough to close all the ESDs, but the pumps just keep pumping away. You might be down for 6 to 8 hours repairing a compressor or dealing with something else, or a third party where you're flowing into has you shut in. So now do you send out your operator to all the wells just to shut down all your chemical pumps, especially in remote fields? That gets really difficult. Through SCADA, now the operator can just go on recycle. Hits recycle. The pump doesn't shut off, it never loses prime, it just sits there and recycles back to tank. Field gets ready to go pick up, the operator hits the choke button to open the well, he just hits run again, program automatically picks back up, you haven't wasted a liquid chemical the whole time that well's been shut in. Big advantages tied into SCADA. Just so you guys know too, we're also working with ZEDI right now. I know a lot of people use ZEDI. I think just about every oil company in Canada has at least one well on ZEDI. We've been teamed up with them and we're working very closely with them, so if you have ZEDI on location, you'll also be able to use this system. Couple case studies that we've done for some of our customers. Case study 1, we examined 16 sites, 13 wells, 2 batteries, 1 pipeline. More pipelines in the system, but this was their major pipeline they were looking about. And we recorded the difference between actual and target injection rates on this next graph. Here's the case study that we do for the client. We do it by well, what chemical they're pumping, their targeted rates, and we take all the inventories from your chemical deliveries and figure out whether you're actually on target or not. So here's a case study we did for this company here. January, they only pumped 2 liters over their target rate for the whole month. Pretty good, they were right on, or their pump was down for a while. Next month they were 47 under, 17 over, 112 over, 49 under, 9. I see this quite a bit when we do case studies. So pump was probably down, maybe down again, gets it going, really gets it fixed good, gets in trouble for over-injecting, trims it back, gets too lean, stalls out, too lean again, gets in trouble, hits it, cranks it up, over-injection, well, it has to trim it back down. So it's just a cycle like that trying to achieve those rates because these rates are really hard to achieve. I mean, 3 liters a day with the TAC steam, even with a 1/4 inch piston, to get good reliability, is hard to do. So this is kind of a case study we do, present this to people at no extra cost, no cost them at all, and then you get this. So 0 would be on target, so you're 0 over, 0 under injection, and you can see just on that first well, well number 1, this is what it looks like. They never really ever hit their target rate anywhere. They're over, under, and this is quite common as operators try to deal with the pumps. We're under, over, okay, we gotta get the pump back online, well, it's too much. Try to lean it back, stalls out, we lose injection. Try to get back going again. It's typically what it looks like. So, case study findings, almost every well over-injected for the year. Most wells experience several months of under-injection, which the board doesn't like to see for sure. And if you have a pipeline failure or tubular failures or anything like that, we know that's a lot more expensive than maybe over-injecting a little bit. Most wells experience several months of under-injection, like I said. Even with under-injection offsetting the over-injection on that case study 1, they still over-injected 8,892 liters of chemical at a cost of $45,000 in over-injection. Some wells experienced no injection because the pumps were down or the wells were down, so that was just noted in the red here. So. Case study 2, well had a target rate, 1 liter a day. Pump had a hard time achieving a low rate consistently. Monthly average rates as high as 6.3 liters a day. Voodoo installed partway through March and made an immediate impact. And here's a bar graph showing you that. Here's the company before. Always a little bit over-injecting, having trouble with the pumps, trying to get them set down to that rate. We installed about the 18th of the month in March, and you can see automatic, instantaneous. We're just about right on target rate the whole time there. This pump here is a knockoff of a TAC steam 5100 standard pump 1/4 inch piston, running at 7.5 liters a day, and with the target rate of 1, injecting in at about 250 kPa pressure, and you can see they've been right on their rates ever since. Any questions?